Dear friends, this is the lecture number 12 of current electricity. In the previous lecture, we have discussed about potentiometer. I have told you what is potentiometer, what is its principle, and also its two applications we have discussed in the previous lecture. And I have told to discuss the questions, how to do the numericals of potentiometer to tell in the next lecture. Now this is the time, but in previous lecture I have told you the theory of potentiometer. How much theory you know, that much is not sufficient to solve the numericals of the potentiometer. That's the problem. Potentiometer, you may understand everything, you may know all the theories, but it is difficult to solve the numerical if you will not know more about it. So today I will tell you something more about potentiometer so that you can able to solve all the numericals. Let's draw the potentiometer diagram. We have drawn in the previous class. This is the potentiometer wire AB. Then we will connect one driver cell, then ammeter, then rheostat. I have told you this is the auxiliary circuit, this part, and this is called driver cell. This is your experimental cell, then galvanometer, then resistance box, then your jockey. Okay, and if a measurement of internal resistance, then we will connect one shunt here with a key parallel to your experimental cell E1. So now I will tell you some formulas of potentiometer so that you can able to solve all numericals of the potentiometer. So now see here, first formula. What is the current passes through this potentiometer wire? Actually, who provide current? Driver cell provide current. And at null point, when the jockey is at null point, no current passes through galvanometer. So this line, no current passes. This line, no current passes. For current flow in this wire, this cell has no role. Only this cell provide current. And that current passes through how many resistors? This is one resistor, rheostat. This is one resistor, AB wire. AB wire is also one resistor, high resistive constant or magnetic wire, that is also one resistor. And if this cell has some internal resistance, also you have to include that one. And what is your current formula? All of you know, current is equal to net EMF divided by net resistance. I hope you have remembered this formula. In cell, I have told you, current is equal to net EMF by net resistance. As current passes through only this circuit, it has no role. So current formula is equal to net EMF E, only this cell. Then net resistance. Net resistance is RH. This AB wire resistance. Then this rheostat resistance. Then if this cell has an internal resistance, the internal resistance also we have to include. Then number two, what is the potential drop happens in the wire? Potentiometer wire. Potential drop, as it is a single wire, so we can use your Ohm's law. So V is equal to IR. Potential drop happens in the wire. V is equal to IR, so I am writing here AB. As it is A to B, the potential drop happens. The I current passes here, and this resistance also I am writing RAB. Okay. Then third is potential gradient. How I will find potential gradient here? Potential gradient, you know, K is equal to V by L from the principle of potentiometer. So V by L means the length what will take, its potential difference also it has to take. Okay, suppose this is the wire. If you are taking this much length, means you have to take the potential difference between those 2 points. If you are taking the length here, also you have to take the potential difference between these 2 points. Okay, so now here, if gradient I will calculate, I am taking from A to B. What is the potential drop between A to B? VAB. And what is the length? LAB. LN, in the whole wire how much potential drop happens, and the whole wire length I am taking. So this is the potential gradient. Then the 4H. Now see, already we know in the application E1 by E2 is equal to L1 by L2. This is the formula from application number 1. That one also you use to the numericals. And R, measurement of internal distance L1 by L2 minus 1. Also this is from the application number 2. But another formula I am writing here, S1 by S2 equal to L1 by L2. This formula actually we have to use to solve one numerical of your NCERT book. I think question number 23 something we have to use this formula to solve. NCERT book also has solved it using this formula. But in this formula little controversy is there. This formula, I think this formula is not correct. But I am telling you as a NCERT book question is solved by this formula. In NCERT book it is given. Okay, what happens? So this resistor, if this resistor will change, now it is S1 and balancing length, now it is S1, so then balancing length is L1, when it will be S2, balancing length changes to L2. Okay, so these 4 quantities, if any 3 quantities will be given, we can find the 4th quantity. But here why it is not right is when S increases, then balancing length increases. S directly proportional to L. I will explain you why. I will tell that one. S, when this S increases, this balancing length increases, but that is not directly proportional. Increases, but that is not directly proportional. Okay, so that's why we cannot write actually this formula. But it is written in NCERT book, so I am giving you to solve that question. The last formula I am telling you. I am now deriving the last one. It's also very important one formula. So you know potential gradient K. K is equal to V by L. So we are writing V is equal to IR by L. Then it is R is rho L by A. Okay. So then this is L. So not exactly this one I want here. I will in while proving the principle, K was I rho by A. While we prove the principle in from V is equal to IR. Okay, then this is rho L by A. So this is the formula. V is equal to IR, then in place of R I wrote L by A. So now see the first one and see the last one. Okay, so what about IL? IL is equal to VA by rho. VA by rho is constant. VA by rho is constant. A is constant, rho is constant. When you have connected a particular cell, then V is also constant. Particular cell you have connected, so V is also constant. When V constant, so IL is constant. In that situation, when a particular cell is connected here, in that situation what happens? IL constant and I can write I inversely proportional to L. IL is equal to constant, so I inversely proportional to L. What do you mean by this? If current decreases in the circuit, then balancing length increases. If in the circuit current decreases, remember balancing length increases. This jockey, if current decrease, this jockey will move towards B, balancing length increases. Remember this one. I is always inversely proportional to L. From this you can derive, you can prove it. So these are the 7 formulas I gave you to solve the numericals of potentiometer. You can solve the numericals of potentiometer if you can remember all these 7 formulas. Again, I am going to another question which always frequently, this question is always asked in exams. What is that question? 4 resistance question. I am telling you 4 resistor question. This is 4 resistor question. I always tell this one. What is the 4 resistor question? First come to question number 1. Resistor number 1. Resistance connected. Resistance connected in series with driver cell. In series with the driver cell means which one? This is rheostat. According to our language, it's rheostat. But in question, it may give like this: resistance connected in series with the driver cell. If question will come in exam like this: if this resistance increase or decrease, what happens to this null point? Null point will shift to where? What happens to the balancing length? This type of question will come. If this resistance increase or decrease, like this 4 resistances will discuss, if they increase or decrease, what happens to the null point? Understand? So now let's come to the point here. So if this resistance increases, let's discuss. If this resistance means rheostat, in my language it's rheostat, but in book it may be written like this: resistance connected in series with the driver cell. If this resistance increases, so current in the circuit decreases. According to formula number 1, you can see the formula number 1. Okay, you go back in the video and see the formula number 1. If resistance increases, then current decreases. If current decreases, then balancing length increases. According to formula number 7, in formula number 7 I have told you, if current decreases, balancing length increases. So this jockey shifts towards B. This is about this resistance. Now come to the next resistance. Next resistance now come to resistance box. Means that will be written like this: resistance connected in series with experimental cell. Experiment cell. So that is resistance box. Resistance box. Okay. So what happens if resistance box resistance increases? If resistance box resistance increases, what happens to the null point? What happens to the null point? Think. No change. No change to the null point. Why no change to the null point? If this resistance changes, it may increase, may decrease, there is no change in null point. Because when null point comes, no current passes through this line. When no current passes through this line, what is the use of this resistance box? What is, if the resistance box is there, but when no current passes, then it has no role. What is the role of the resistance box? You may increase, you may decrease, doesn't matter. So when the null point is there, you get the null point. At that time, if you change this resistance box, as no current passes, its reason you can write. Its reason is because no current passes through RV, through that resistance box. No current passes through this resistance box. At that time, when null point comes, so there is no change in the null points. But the question is coming to your mind now. Then why is that resistance box is connected? Why will you connect that one if it is not affecting the null point? You see, when suppose you have not got the null point, you have not got the null point. When you have not got the null point, first initially to get the null point, what you did? You now touch the jockey here. Your galvanometer pointer deflects like this. You see the galvanometer. This is the galvanometer pointer. It deflects like this. When you touch the jockey at point B, the galvanometer pointer deflects like this. At A, at B, the galvanometer pointer deflects like this. At that time, current passes through this line or not? Yes, that time current passes through this line. But if this resistance box you will not connect, if you will not connect this resistance box, suppose you don't connect this resistance box, then now you see what happened to the galvanometer pointer. If you touch at A, if you touch at B, the pointer will suddenly the pointer will go to the extreme and the pointer will behave like this, you see. and here also at B, when you touch it go and it behave like this. Means what happens to the pointer? Because your current is very high. Current is very high, the pointer suddenly go and strike the end. At that time there may be the chance to damage the galvanometer. There may be the chance to damage the galvanometer. Then to avoid that, to protect our galvanometer, simple 3 words. Why this is connected? Also this question comes in exam. Why resistance box is connected? To protect galvanometer. 3 words you will write, you will get 1 mark. Nothing more required to write. Why resistance box is connected? To protect galvanometer. If you will connect this resistance box, then what will happen? How much resistance will give while doing that experiment? It is not that only we connect the resistance box, we have to also give some resistance, taking out the knobs from the resistance box. Okay, then how will apply? You see, you first resistance box is connected, no resistance is given from it. You touch this at point A, pointer immediately that pointer comes to the end and behave like this. Then what will do? Then at that time from the resistance box you now give some resistance. Suppose you give 500 ohm. Give 500 ohm like this. If you give 500 ohm, again the pointer is going and behaving like this. Now give 1000 ohm, again the pointer going and behaving like this. Now you give 2000 ohm, you will try like this. You give 2000 ohm from here, you will give 2000 ohm. Now the pointer is going like this. Smoothly the pointer is going and without touching the end, the pointer remaining close to the end. And when you touch to the B, again the pointer is smoothly going and touching and just very close to the end without touching it. Means no harm will happen to your galvanometer. Means you just take up 2000 ohm. That varies according to your instrument, according to your cell, according to your experiment. You will see how much resistance will give according to that. So you now understand what is the role. It is only connected to protect the galvanometer. Then come to resistance number 3. This is the shunt. Which shunt? Shunt, what in exam, what will get its name? It's I am writing shunt, what will get? That cell connected parallel to resistance connected parallel to experimental cell. Resistance connected parallel to experimental cell. If it is connected parallel to experimental cell, this is its name is shunt. Resistance connected parallel is called shunt. Okay. If you increase the shunt, then what will happen? What will happen if you increase the shunt? I am writing the shunt here. I am writing the answer here. Shunt increases. This resistance increases. What happens to the balancing length? What happens to the null point? If this resistance increases, potential difference here increases between the two terminals of the cell as well as across this shunt. What is the potential difference between two terminals of the cell? That is the potential difference across the shunt. If this resistance increases, potential difference increases. You may ask the question, sir, how? You all have done one question, one graph you all have done. V versus R. Potential difference between the two terminals of the cell and the external resistance or potential drop across the external resistance versus external resistance. If external resistance increases, what happens to the potential drop? So you have drawn this graph. You just recall you have drawn this graph, very important graph, and this is E, EMF E. The graph will go like this and touch V. So when R increases, V increases. Understand? From this graph, now you understand? You all have done. This is a very important question always comes in exam. When R increases, V increases. So when shunt increases, then V also increases. If V increases according to principle, length increases. So this is the answer of question number 3. This is the region. This is the region. In exam, the question will ask with region. The balancing length increases. Then comes to the internal resistance of the driver cell. Internal resistance of the driver cell will change, then what happens to the null point? Then now going to 4 question. Question number 4 I am writing here. Internal resistance of the driver cell, that is R, small r. increases. From the formula number 1, what just before I told you, formula number 1, if internal resistance increases, current decreases, so balancing length increases. If internal resistance of the cell increases. But this question actually is in your NCERT book, question number 22. Question number 22 and B it is there. If internal resistance will change, then what happens to the balancing length? Okay, but the answer is written in NCERT book, no change in balancing length. But this is the discussion according to our formula, according to our discussion. If internal resistance will change, then balancing length will must increase. But in NCERT book, the answer is written no change in balancing length. But you can write the answer with proper explanations, and this is the reason why the balancing length will increase. Okay, so this is about the 4 resistor question. Then we go to again another question which is frequently asked in potentiometer. The next question is, see, the next question in potentiometer is, now sometimes when you do the experiments, all connection over, you know the circuit is looking complicated, you have done all connections, spending some time to get the null points. But after connection, when you bring the jockey and it touch at point A, galvanometer pointer deflects like this. When again you take the jockey and touch at B, galvanometer pointer deflects like this. How do you understand? When touch at A, pointer is like this. When touch at B, pointer is like this. Means this pointer will not go to 0. This pointer will not go to 0. So it's called one-sided deflection. It's called one-sided deflection. If one-sided deflection, what are the possible faults in the experiment we have to see? We have to see what are the possible faults. We can able to check in our circuit what mistakes we have done for which the galvanometer is showing one-sided deflection. Okay, now it's also one question comes in exam. If one-sided deflection of a galvanometer, what may be the possible faults? So first fault I am telling you, sensitivity may be less. Sensitivity of a galvanometer may be less. Sensitivity is less. If sensitivity of galvanometer is less, then your sensitivity of potentiometer is less. If sensitivity of potentiometer is less, then it will show one-sided deflection, will not get 0 point. Null get null points, will not get. What do we have to do? If sensitivity is less, I have already told you how to increase sensitivity by increasing this resistance connected in series with the diversion. If we increase this resistance, then current decreases in the circuit and potential gradient also decreases. Potential gradient also decreases. Potential gradient K is equal to I rho by A. Current decreases, so potential gradient decreases. If potential gradient decreases, then potentiometer will be more sensitive. It may measure. If it cannot measure one-sided deflection it is showing, it can measure. If sensitivity may decrease, sensitivity is less, fast or different. Fast, now defect you can able to detect. If you are increasing this resistance, now the balance point is coming, then it's okay. That was the problem, is clear. Then what may be the second fault? Second fault is this positive of the driver cell is connected to A, positive of the experimental cell also connected to A. Also connected to A. If positive both are connected, then it's right. But if the positive of the driver cell and negative of the experimental cell you have connected, suppose you don't know the circuit, you don't have the knowledge of the circuit, clear knowledge, if you are connecting positive with negative of this experimental cell, see negative of the experimental cell, Then what happened here? You will not get the null point. You will not get the null point if you connect negative here. Also, it will show one-sided deflection. The galvanometer will show one-sided deflection you will connect. So that means positive of the driver cell has to be connected with the positive of the experimental cell. It's a wrong connection. Then the next is this is the one positive of driver cell and positive of experimental cell should be connected at one point. So if they are not connected, then you will not get the one-sided, then we will get one-sided deflection. Then come to the third point. Third point. Now let's check the third point. I am explaining the third point. Suppose this is 4 volt. Take the example to explain this one. This is 4 volt. This is 0. You now neglect this RH. Neglect the rheostat. This is 4 volt. All potential drop happens here. You are taking this is suppose 2 volt. If they have taken this is 2 volt, this is off. S is not connected in the circuit. Only this cell is connected. If this is 4 and this potential difference is 2, then this will be 2 volt. This point will be 2 volt because potential gradually decreases. 4 volt, 3 volt, 2 volt, 1 volt and 0. If the null point is here, the difference between 4 and 2, this is 2 volt, so this EMF is 2 volt. Okay? If this EMF will be 3 volt, suppose I have connected one cell of a 3 volt. If the EMF is 3 volt, what happened? Now this jockey will move to this point. You see. Now this jockey will move here. Jockey will move here now. Clear? If this is 3 volts, we will get the null point here. At 4 when we will touch. At 4 when we will touch the galvanometer, our jockey will touch at 4. At 4 means at A will touch. It will show the deflection like this. When you slide and move, then gradually it decrease means deflection decreases. Deflection decreases and it comes to 0. Here. Deflection decreases and it comes to 0. Understand my point? Okay. Suppose you have connected 4 volt here. Cell is now 4 volt. Now where the jockey will touch, the jockey will go like this. And the jockey will touch at the end. The jockey will touch at the end. If you connect 4 volt. Cell is 4 volt. What happened here? So now when you touch at A, like this, jockey like this, when you touch at B, or when you go like this, sliding like this, when you go sliding on the wire, gradually you see the jockey movement. Jockey will now deflection decrease, and when it will touch B, the deflection will be 0. Understand? Suppose I am taking this 5 volt. What happened? You touch at A, jockey you touch at A. When jockey you touch at A, its deflection is like this. When you slide the wire, deflection decrease. Deflection is always means angle with vertical. Angle with vertical because 0 is on the vertical. Okay, deflection decrease. Can it be 0? It cannot go to 0. Why it cannot go to 0? Because you have connected 4 volt. You are getting 4 volt. You are providing 4 volt potential difference. But you are going to measure 5 volt. From where it will give 5 volt potential difference? When you connect 4 volt here, the jockey go to the extreme end. When you are again going connecting the 5 volt, then the jockey, where the jockey will go, it is already in the extreme end. But deflection at point A, deflection is like this. When you go sliding the jockey on the wire, deflection decrease, but it will not be 0. Deflection will not be 0. At point A, deflection is maximum, and at point B, when you go, deflection, when you go towards B, at point B, deflection is minimum, means deflection is decreasing. At point A, deflection maximum. When you go forward, deflection is decreasing, but it cannot go to 0 because this cell EMF is more. This cell EMF is more. So another condition here. So if you are not getting the null point, if you one-sided deflection, this cell EMF may be more than this cell EMF. Experimental cell EMF greater than driver cell EMF, which should not be. Experimental cell EMF should not be more than driver cell EMF. Always this EMF should be greater. Remember, driver cell EMF always should be greater than experimental cell. So if you have done this mistake, you will not get the null point. Here I am writing as where we are not getting the null point means positive of the driver cell, you have connected with the negative of experimental cell. Okay, negative of experimental cell, but it should be connected to positive and positive. I am writing these points when you are not getting the null point means one-sided deflection. What are the cause? What I am writing here, it should not be. What I am writing here, it should not be. Now everybody understand? But from this, another thing also we get. What is that? You see, at point A, jockey deflects maximum at point A. But when we are going towards B, deflection decrease, but cannot touch to 0. So we are not getting the null point. Cannot touch to 0. We are not getting the null point because this cell EMF is more. This cell EMF is more. But what extra thing we got here now? That one I want to inform. So if at point A deflection is maximum, and when the jockey goes towards B, the deflection decreases. See here, this point you mark. Deflection decreases when you go from A to B. Means connection is correct. This cell EMF is more. If it decreases, because in exam the question will come. If deflection decreases when one moves from A to B, which terminal? This is written as X and Y. X is positive or Y is positive? Or which one is positive and which one is negative? Which one is positive and which one is negative? Means deflection decrease means your connection is correct. Connection correct, but only cell EMF is more. This cell EMF is more. That means connection correct means this positive and this positive are connected. Means X is positive. X is positive, or the terminal which is connected to A is positive, but U1 EMF is greater than E. If deflection decreases when we are going towards B, deflection decreases. It wants to be 0, but it cannot because your cell EMF is more. Okay, but if deflection increase, suppose deflection increases, means your connection is wrong. Increases means you see, at A when you touch, the galvanoid deflects like this. Small deflection, deflects like this. And when you go towards B, the deflection increases. It should come to 0, but it is going away from 0. At A when you touch, small deflection. At B when you touch, more deflection. Means deflection increase. Means the connection is wrong. You have done wrong connection here. First, that means you have connected X with negative. Means X is negative now. X terminal is negative and Y terminal is positive. This is also one question in your exemplar. In your NCERT exemplar book, this is also one question. Means if one side is there, deflection is there, first what you do, you will increase the rheostat. If you are getting the null point, then it's a good, problem over. If you are not getting the null point, then come to the next point. Now you check whether deflection increases or decreases. If deflection decreases when going from A to B, means your connection is correct, but this cell EMF is more. So you have to increase this EMF. If this is 5 volt, you connect to 6 volt. If this is 6 volt, you connect to 10 volt. Like this. And if deflection increase, you mark that while going towards B, deflection is increasing. Then what you do there means you have done wrong connection here. You just reverse the terminals. You can check if it is one-sided reflection. You can check yourself what mistakes you have done. This question also always comes in exam. So these are the different type of a question how to solve potentiometer. So now I told you to solve the different type of questions of potentiometer, and you can also solve more questions from your NCERT book. Question number 22, 23, 24, those questions also you can solve from your NCERT book. And one question also your NCERT book example, the last question, which is very important question, also come in the previous year exams. Though it is written potentiometer question, but that not exactly potentiometer question, that is just combination of resistor question. You can also solve that question, that is also very important question. Thank you.